Hello friends, welcome to my channel. Let's have a look at a newly appeared problem. Problem 2517. Maximum tastiness of candy basket. In this video, we're going to explain a solution based on binary search. First, I'll read through the problem statement to digest the problem, and then we do the analysis, and finally we explain the code. First, let's look at the problem statement. We are given an array of positive integers called price, where price I denotes the price of the ice candy at a positive integer k. The store sells baskets of k distinct candies. The tastiness of a candy basket is the smallest absolute difference of the prices of any two candies in the basket. So we are required to return the maximum tastiness of a candy basket. So here are three examples. Let's first look at example 3. So as all the prices are the same, so the output is 0 here, right? And in example 2, so the output is 2. So as you can see, we have 1, 3, 1. So in other words, 1, 1, 3 after sorting. So in example 1, so the output is 8. So one example is that we have 5, 13, and 21. So the differences of 8, and 16, right? So due to the problem requirement, we need to return 8 in this case. So before we go further, let me first emphasize that. So in order to get the tastiness, it's good to do sorting. However, the price list is not necessarily already sorted at the very beginning. So with that said, let's also look at the constraints for this problem. First, k is bounded below by 2 and bounded above by the price length, and the price length is bounded above by 10 to the power 5. So 10 to the power 5 is actually a decent large number. Secondly, so the price is not negative. So in fact, it's positive because it's greater than or equal to 1, but it's bounded above by a large number, 10 to the power 9. So with that said, we are ready to do the analysis. So in this video, so we are going to explain a solution based on binary search. So here, first let's make a comment. So this problem is actually a standard application case of binary search. So we are going to explain the general procedure by this example. So first recall that, so in general binary search, so we need to do two things. So first, we need to define a Boolean function to produce monotonicity. So this actually is not trivial, because in some problems, the monotonicity is readily there. For example, if we want to find an element in a sorted list, so in this case, the order is a natural order there. But in general, it can be very hard, or at least not trivial. So this is the first item. The second item is to determine search range and do proper search range shrinkage. So this is also not a trivial thing. So because we need to pay attention to the boundaries and pay attention to how to do proper search range. And finally, actually, we also need to know how to do the return. So for this problem, we are going to do the explanation while we're doing the coding. So here is another comment. This problem has some hints here. Actually, the hints for this problem almost readily give a full solution. So actually, you can do more practices. So you are welcome to check the playlist in our channel for a number of Leetcode problems that can be solved using binary search, especially for digesting the thought processes to address the two ingredients in binary search in different application cases. So with that said, let's do the coding. So here we're going to explain the problem logic while do the coding. So first, I'm going to make some preparations. So for this, first I'm going to get the length of the price list. So this is just for convenience. Also, we want to do the sort. So the purpose of doing the sort is to compute the tastiness. The reason is that after we do the sort, so the smaller gap is in the consecutive elements, right? So we just need to use the larger one minus the smaller one, right? So this is the preparation. The second step is to define the Boolean function to produce monotonicity. So this actually will encode the problem logic. So here I'm going to define this function as fulfill. So here as t. T will be the tastiness. So here we are going to check if k distinct caddies can achieve tastiness no less than k, that is greater than or equal to k. So in other words, we do this check and we return true or false. In other words, this is a Boolean function. So first, we're going to initialize the count to be 1, right? And then the last price is price 0. So this count equals 1 is counting the first caddy after we do the sort, right? This count is we just need to return if the count will be greater than or equal to k, right? So and then we just need to do the for loop for I in range. So now because we have used the first caddy after sorting, so we actually start from 1 and then ending at n-1. So then we check if price I minus the last price. So this will produce the smaller gap, right? If you check the tastiness definition, so it's the smallest absolute differences, right? So the smallest absolute difference will occur in the consecutive two caddies after sorting. So right, so we just need to check if price I minus the last price is greater than or equal to t. If this is the case, we are going to do the counting by 1, right? And then we are going to set the last price to be price I. Right. So finally, we just need to return if the count will be greater than or equal to k, right? So this will be the fulfill function. So you can further digest the logic here, or you can look at the hints. So this is the second step, so which will produce the monotonicity for the next step. In other words, the binary search, right? So here the two task is to determine search range, and also do proper search range shrinkage. So for this, actually the above Boolean function, we can using the above Boolean function, we can translate this problem to be find the max t such that fulfill t is true, right? So this is the key transformation step. So here the smallest gap possible is 0 for sure. So the highest possible will be the largest element minus the smallest element. So the low will be 0 and the highest will be price -1 minus price 0. So this means the largest element in the price list after sorting. So this will be the smallest. So the let me speak like this. So after sorting, the last element will correspond to a occurrence of the largest element. The first element will be corresponding to a smallest element, and then this will be the largest gap. So here we're going to, high is greater than low, so we are going to start from the large to small. So right, so we do shrinkage like this: mid equals high minus the gap, so high minus low into division by 2, right? And then we're going to check if fulfill made. If this is true, right? So if this is true, so we are going to set low to be made. Notice that fulfill low is still true, right? Otherwise, so if fulfill middle is not true, is false, right? In other words, t is too the tastiness using middle is too large. So we're going to set high equals mid minus 1. But at this stage, we are not sure if mid minus 1 is still too large, right? But in the process, we are sure one thing, that is low will always true. Then next, when we do the return, we need to return low, because low is the invariant such that invariant quantity in the sense such that fulfill low is always true, right? So we are going to return true in this case. So here I would like to point out that so here high is greater than low. Of course, it is equivalent to low less than high. But here I want to emphasize that we are doing the shrinkage from the larger half and checking the larger half. So we are going to from the high to low, right? So that's why we use high minus the gap over 2. And then we check fulfill middle. So in this case, because of this setting, fulfill low is always true, right? But this is not fulfill high is not necessarily always true. So due to this logic at the ending, so we're going to return low. Yeah. So with that said, this is a solution format using standard binary search. So let's first do a check, I guess. Yeah, it passes one example. So now let's look at generic case. Yeah, it passes all the test cases. So that's about it for this specific problem. So here let me emphasize two things. First, so the two ingredients in the binary search. One is a Boolean function to produce monotonicity, and the other is to determine search range and do proper search range shrinkage and finally return. So both the two ingredients can be non-trivial in different use cases. We need to define the Boolean function and do the shrinkage based on the specific use cases, but the general principle is the same. So this is one thing. Another thing is that we have a playlist which actually consisting of problems that can be solved using binary search. So you're welcome to check out. So with that said, I guess that's about it for this video. Thank you.